Okay, so for this lesson, we're going to start getting into how to use your multimeter. Now, with your multimeter, it is really one of the most important tools you have as an HVAC technician. It really is the tool that you should be going to first when you are doing service. Your meter is the only way and the only tool that you have at your disposal that you can physically check where voltage is and is not, and seeing whether or not you have a good or a bad load in a system. Okay, one thing that you have to make sure that you do is when you're looking at multimeters is make sure that you are getting the correct meter that you want for a particular task, because there are lots of different meters out there that have many different ranges and functionalities that you are going to see. What you really want in a multimeter, especially in HVAC, is you want one that's going to be able to take voltage readings in both AC, DC. You want it to be able to take resistance readings, microamp readings, temperatures. You want it to really be able to take a majority of your most common readings, even amperage and stuff like that. So you want to make sure that you read the manual that comes along with it and make sure that you know how it works, how it's supposed to function, where you're supposed to put your leads and all that stuff. Okay, but really in the world that we have today, is we have really kind of like two real basic type of meters. You have your analog and your digital. Your analog has obviously been around for a very, very long time, well before digital meters came out. They are extremely sensitive to voltages and amperages and stuff like that, but they do not really stand up well to being dropped or mistreated in any way. Okay, they are still used today by many technicians that are out there who are looking for really extreme accurate measurements, especially if you're maybe troubleshooting a unit that has some DC functionality to it, like DDC controls and stuff like that. You may want to use an analog meter to really kind of fine-tune what your actual readings are. Then you have your digital meter. Okay, these obviously are kind of really more taking the place and replacing analog ones, simply due to the fact is that they are much more rugged. They can be handled, dropped, and tossed around. They have a lot more functionality in some cases than the analog meters. Some of these meters are able to take temperature readings and take all sorts of different types of measurements, continuity, resistance, microamps, micro this and micro that. Okay, digital meters are accurate and are usually auto range, which basically means is that if you forget to turn the dial, say from DC to AC, it'll automatically do it for you. Just a nice other feature that some of these meters have today. There are several basic electrical rules you still must follow and understand prior to comprehending what a meter is actually telling you. So most of these rules are based again on voltage, amperage, and resistance. So one thing that you need to remember again is a series circuit. You will see series circuits in a lot of your HVAC equipment. Again, remember, a lot of your safeties are wired in series. Remember, series means that they are in the same line as each other. Okay, so here's an example. Here's one load, second load, third load, or a switch, whatever way you want to do or look at it. Each one of those balls are in series with each other. Parallel is next to. Okay, but they never converge on each other. Okay, parallel. Okay, like I always like to say, a three-lane highway. These bulbs are in parallel with each other. If this guy happens to crash into the median, These two cars just continue on by and it doesn't affect them. Okay, an open circuit are circuits that do not have a complete path for electricity to flow. Okay, remember, circuits require a source, switch, path, and a load. If any of these circuits happen to break or open, then that circuit is not complete and that circuit will not work. The circuit is open. Okay, here's an example of an open circuit. We have a switch that is in the open position. When the switch is in the open position, that load is off. It is not working. When you measure voltage across an open circuit, you will always get a reading of source voltage. Remember, source voltages can be 24 volts, 120 volts, 208, 230, 277, 480, whatever is being supplied to that circuit. It could even be a 9-volt battery on a flashlight. Okay, if that circuit is open, you're going to read 9 volts. Okay, when you measure resistance across an open circuit, you will always read infinity, or OL, on your meter. Okay, a closed or complete circuit is one that has a complete path, source, switch, and a load. Okay, the load is operational in a complete circuit, which means it's working. The switch is closed in a complete circuit. Here's the example of a complete circuit. Our switch is closed, our bulb is on. Okay, when measuring voltage across a closed switch in a complete circuit, you will get 0 volts across that switch. When measuring voltage across a complete circuit, you will always get source voltage. Voltage across a load is identical if the load is working or not. Okay, if you have all switches closed and measure voltage across the load, the circuit is good. If the load is not working, then you have a bad load. If the load is working, then the voltage you read is the voltage that load is using. Remember, that is voltage drop. The current or amperage you measure will be 0 volts or 0 amps in an open circuit. If the circuit is closed, the amperage you measure will change based on where you take your readings. The best place to take an amperage reading on any load is as close to it as possible on your neutral wire. Okay, measurements that your meters will most likely have is your voltage, current, resistance. It'll measure capacitance for your capacitors, frequency, and temperature. Okay, voltage is one of the most important readings that you are going to take when it comes to troubleshooting a system. So when you're definitely taking time to measure for voltage, you want to make sure that you have your meter in the correct setting. Okay, usually there's going to be a V on the dial. Make sure that that dial is set to V, which measures volts. Make sure that your leads and everything are plugged into the correct spaces on your meter. You're going to put the leads in parallel with or next to the point in the circuit you are trying to measure. Hold those leads steady without touching any other metal to your finders or each other, and then watch the display on your meter to stabilize on the number, and then that's your voltage reading. Okay, so voltage across an open switch, you will always read source voltage because we are now picking up that difference in potential. Remember, electricity always wants to try to follow the path of least resistance. So with this case, this switch being open, the electricity will actually kind of pass through the meter, and it will pick up that 120 volts. Once we close that switch, our meter will now read 0 because it is no longer picking up that voltage. So it is now passing through the switch and into the load. When we are measuring voltage across a non-powered load, simply because the switch is open, we are going to read 0. There's no voltage being applied to it. When I close that switch, I am now powering up that load. I am going to read source voltage, and in this case, we're reading 120 volts of electricity. That load should be working. Voltage across an open load you are still going to read 120 volts. Why are we reading 120 volts? Because our load is now acting like an open switch. Our meter is picking up that difference in potential, but yet that load is not working. To confirm that this load is in fact bad, we would take a resistance reading across it, and we would see that we would read OL because the winding inside there is actually open. Okay, voltage across your full circuit, you are always again going to read source voltage, in this case 120 volts. So when we're measuring resistance, we want to make sure that we disconnect the circuit from the source. And with resistance measurements, there cannot be any power on that circuit. Okay, we want to then decide what component or portion of the circuit we want to measure. We are going to disconnect or isolate that component from the rest of the circuit, and then we are going to set our meter to ohms. Okay, we're going to touch one lead directly to the other. This will show a reading of 0 on your meter. The reason why we do that is because we want to make sure that the meter is indeed working correctly. If it does not, check your leads for damage and make sure that they are plugged into the right spots on your meter. And now touch one lead to each side of the component or isolated portion of the circuit that you are testing. Wait for the number on the display to stabilize and then record the number. This is that resistance reading. And again, remember, resistance is measured in ohms. Okay, so here we are, resistance across an open switch. I'm going across before and after my switch number 1 here. We will see that it's open. Our meter will read OL, open load, as I like to think about it. Okay, when I go across a closed switch, I'm going to read 0. It's telling me that between point A and point B, I have a complete path. It's 0, not picking up any sort of resistance. Remember, a switch has no resistance to begin with, so you should have 0 resistance across a closed switch. When I'm taking a resistance reading across a good load, I'm going to read some resistance reading, whatever it may be. No motor load in HVAC has the same resistance. We are looking for some number. If I read OL across that load, it's telling me that that load is open. Okay, to measure amperage. Okay, to measure amperage, the first step is to determine which type of amperage you want to use. Okay, you have 2 types of amperage readings that you can use in the field. However, one is more common than the other. You have your clamp-on type meter, which is going to be used for high voltage and currents, and then you have your inline type, which is going to be used for your lower voltages and currents. Okay, so here is your clamp-on meter. So you got to make sure you close the switch to energize the circuit in order to get an amperage reading, because remember, amperage is also a byproduct of the electrons moving, so we have to have power on in order for us to get an amperage reading on a particular piece of equipment. So to measure current with a clamp-on meter, make sure the system is running and on. Clamp the meter around a single wire and wait until the number stabilizes. You cannot take an amperage reading on more than one wire at a time. If you put a bunch of wires inside the clamp, all it's going to do is cancel out and you're going to read 0. Okay, so make sure that you have one wire at a time. Wait for that number to stabilize and then you will have an amperage reading. Okay, if the current is too low, you may want to consider using an inline amp reading. Okay, if this is not possible, a way to get around that is take the wire and wrap it around the clamp about 5 or maybe 10 times if you can do so, and then take a reading. Okay, how to take that reading is you're going to divide the number you get by the number of times you wrap the wire around the clamp. Okay, measuring using an inline meter, all you're basically doing is taking the meter and putting it in line with that circuit and taking an inline reading. You may use this on 24-volt circuits or even 12-volt circuits in some cases, depending on the unit that you're working on, but it's probably not really that common of a task to use. A lot of people just simply use your clamp on and get your readings that way. Okay, so again, when you're taking an inline current reading, again, you have to make sure that the power to the circuit is off. You're going to check for your voltmeter to verify this is the case. Okay, always never assume that the power is off. You want to definitely double check that it is indeed off. You are going to disconnect the wire directly before the component you are concerned about and put the meter in series or in line with the component to complete the circuit. Make sure that the meter is set to amps and the leads are plugged into, again, to the correct spots. You're going to turn the circuit back on and then allow the display to stabilize on the meter, and again, that's going to be an amperage reading. Okay, to make sure you know the levels of voltage and current your meter is rated for, never exceed the voltage or current, and if you suspect it is closed, use a clamp-on meter. Okay, unfortunately, most of the time you will not just have one switch that's controlling a load. You may have multiple switches that's going to control a load. Like in most HVAC industries, you're going to have a lot of control devices. So you must have a reliable and organized method of troubleshooting these types of circuits, and that's known as the HOP-SCOTCH method. Okay, this is why most good technicians start diagnosing a problem using the HOP-SCOTCH method to trace out your circuits. Okay, and this procedure is relatively simple. The first thing that you want to do when you are using the HOP-SCOTCH method is make sure that your meter is set to volts and make sure that the leads are correctly plugged in to the appropriate places on the meter. It is important to note that the HOP-SCOTCH method of troubleshooting only applies to circuits up to 120 volts of electricity. Okay, now what you're going to do is check for voltage across the two endpoints of the circuit, your line and neutral. Okay, so here we are. The beginning part of doing the HOP-SCOTCH method is you have to make sure that you do indeed have voltage to your circuit. So you're going to go across L1 and neutral. In this case, 120 volts is being read. You are then going to leave one lead at the beginning of the circuit, usually on your black wire, your line 1, and HOP-SCOTCH your way through the circuit. So here we are. Voltage across L1 and neutral is 120 volts. We have power to that circuit. Again, leaving one lead at the beginning of the circuit, you are now going to take your other lead and just simply move your way down the circuit. So in this case, we are reading 0 volts between the beginning of the circuit to our switch. We are reading 0 volts here because we are reading nothing more than a wire from point A to point B. There is no difference in potential there. So we are going to read 0. We go after the switch, we read 120 volts. Why are we reading 120 volts? Because remember, voltage across an open switch, you will read on source voltage. If we go across neutral, we see that we have 120 volts. Now, we can verify the problem by doing it the opposite way, starting on the neutral side of the circuit. Again, going from neutral to the wire connecting to our load, we read 0. There's no difference in potential. I go across my load to the other side, I'm reading 0. Well, if I'm not reading any voltage here, that's telling me that there is no power being supplied to my load. And if I go across my switch, I read 120 volts. And again, reading 120 volts, that switch is open.